Hello. Now we will calculate the work done in isobaric process. As you know, the formula for work done is PdV. This is for the closed process. And for isobaric process, we already have the relationship, the analytical formula. The formula for isobaric process is P naught V is RT, nRT. This is the formula where P naught is a constant. So this formula represents the isobaric process. Okay, this formula we get by putting the value of pressure into the isobaric equation, this ideal gas equation. Okay, so if this is the formula, you can see in this formula dWg is P dV, and for isobaric process pressure is constant, and that pressure I am assuming as P naught. So if we put the value there, we will have dWg is equals to P naught dV. So in this case, you see there are two variables. One is W and second is dV. P naught is a constant. So if we do integrate this, if we integrate this, we will get dWg is equals to P naught dV. We have taken P naught outside of the integration sign because P naught is a constant. So let's say initially the volume was V1 and finally it becomes V2. So W 0 to Wg. We'll integrate the left hand side, which is dWg, will give us Wg. This is the work done by gas, and that will be equals to P naught integration of dV is V from V1 to V2. So Wg comes out to be P naught V2 minus V1. So this is the work done. This is the work done in case of isobaric process. And the formula is in terms of pressure and volume. Okay. Now, if we want the formula in terms of temperature, that also we can calculate. So you can see there, this equation you can see. So what I'll do, this V1 and V2 are the initial and final temperatures. So let's say initially the volume was V1 and the temperature was T1, which changed into volume V2 and temperature T2. So initially I'll put the equation, I'll put the values in ideal gas equation. So from ideal gas equation, we'll have P naught V1 is equals to nR T1. This is one. And if we put the second state into the equation, we'll get P naught V2 is nR T2. So you'll subtract equation 2 from equation 3. If we subtract equation 2 from equation 3, we'll get P naught V2 minus V1, that will be equals to nR T2 minus T1. So you see, from equation 1, this P naught V2 minus V1, we can replace it here. So from equation 1, if we replace the value, work done by gas comes out to be nR T2 minus T1. This is the equation for work done in terms of temperature. So this is the equation for work done in terms of temperature. If we want the differential equation out of this, we'll write dWg is equals to nR dt. This will become a differential equation for work done by gas in isobaric process in terms of temperature, which we can use further. Okay, so we have calculated the work done. We have calculated the work done for isobaric process in terms of volume as well as in terms of temperature. These equations we have got. Either of the equation we can use to solve the question depending upon what are the values given in the question, whether they have given the temperature or in the question they have given the volumes. Okay, thank you.